In this video, we're going to take a look at how to solve a quadratic formula by completing the square. So to begin, I'm going to start with, normally we like to be equal to 0, like if we factor or use quadratic formula. With complete the square, we actually don't want to be equal to 0. Instead, how I prefer to begin these problems is grouping any terms that have an x on one side of your equation, and then any terms that don't have an x in them, like that 4, moving that to the other side. So by subtracting 4, or moving that, I'll have a negative 4 on the other side. Now, that's how I'll begin all these complete the square problems. Now, you probably noticed I left a little bit of a space there. Well, what we're going to do right there in that space is find what I call the magic number. If you watched our last video, you heard me talk about that and the way to find that. But here's the thing, since we're now dealing with an equation's basically a scale, a balance, and you can't just add something to one side of the equation without adding it to the other side. And so what I'm going to do is actually put 2 blanks down to show that I'm adding the same value to both sides of my equation. Okay? From here then, I guess I need to find that magic number, that c value. And if you recall the formula, to find c, it was to take half of b, divide b by 2, and then square that result. So what I'll do is I'll take negative 12 in this case, that's my b value. So I'm going to do negative 12 divided by 2 and get negative 6. And then I'm always going to put that number in parentheses when I square it. Negative 6 times negative 6 is going to get me a positive 36. So that will be my magic number that I'm going to add to this side of the equation. But remember, to stay balanced, to keep this equation true, I've got to add that same amount to both sides. Okay? Usually this is the part people get stuck on. They can find the magic number, they can add it to both sides, but they forget what to do. And if you, again, recall from the last video, we said the whole point of this magic number is that it allows you to factor this side of the equation. And so that's my next step. I got to find 2 numbers that multiply to 36 and add up to negative 12. And the 2 numbers that will do that are going to be negative 6 and negative 6. So this will factor into x minus 6 times itself, or if I'm looking to save some space, x minus 6 squared. That's where this process gets its name from. We've completed the square, meaning we've made something to the second power. It'll always factor this way. That's why it works. On the other side then, I'm going to have equals 32, and a lot of people seem to get real confused where that 32 came from. All I did was I added those 2 things together. Negative 4 plus 36 is 32. That's all I did. Okay? And once you get to this point, hopefully things are looking familiar to you because we've already solved equations that have looked like this previously. And so let's see what we can remember about that to finish this and find my answer. So since I have something to the second power, I'm going to go ahead and take a square root of both sides. When I do that, taking the square root of something squared cancels it out. And since those parentheses no longer really serve a purpose, I'll just go ahead and drop them off. So I have x minus 6 equals. And then let's talk about this square root of 32. I know 32 is not a perfect square, so I don't want to get a decimal. Instead, what we'll do is we'll go ahead and break this down like we've talked about. So I'll go ahead and say 32 could break down to 4 and 2, or 4 and 8, sorry. 2 would break down to 2 and 2, and then I like to just with 8 make it 2, 2, 2 right away. So I get all these sets of 2's. And I'm looking for pairs of them, so there's a pair of 2's I can take out. There's a pair of 2's I can take out. So altogether I'll have a 4 out front. 2 times 2 gets me 4. And then I'll have that single lonely old 2 left over, so 4 square root of 2. Hopefully you're also recalling, though, when we dealt with square roots previously, anytime you're solving with them, you're going to get 2 answers. So I'll throw a little plus or minus on my answer, or my square root. Okay. After all this work, though, unfortunately, we're still not done. Remember, our goal is to solve. We want to know what x equals, and right now we don't have x equals. I have one more step to do, and that's getting rid of this negative 6. And so to do that, to get rid of a negative 6, we'll simply add 6, or I like to think about it as just becoming a positive 6 on the other side. I'll write that down first. And then what was already there was this plus or minus 4 square root of 2. And because I can't simplify any further, 6 and 4 square root of 2 aren't like terms, this becomes my answer. And even though it looks weird and kind of awful, that's the solution. Those are the 2 solutions to this quadratic equation using completing the square. And just to make sure we got it, let's do one more example, although if you want to pause the video at this point and try this one on your own, that might be a good idea. So to solve with completing the square, remember my first step is I actually want to not be equal to 0. I want my x's gathered on one side, and then everything without an x, all my constants, moved to the other side. So that 5 came from adding the 2 to get that moved out of there. Okay, so I left a little space. That space is to find the magic number, and as we just talked about, we want to make sure we add that same number to both sides to stay in balance. So now let's find the magic number. And I know many of you can do this in your head. There's a reason I'm writing the steps down, though. I didn't talk about that in the last example, so I'll talk about it this time. Half of 10 is 5, and then 5 squared gets me 25. So 25 is the magic number I want to add to both sides of my equation to stay in balance. Okay, and then the whole point of doing this, because usually this is where people get stuck, is now that I've added that 25, now I'm able to factor this side of my equation. So I'm looking for two numbers that multiply to 25 and add up to 10. And the two numbers that will do that are 5 and 5, or x plus 5 squared. Now the reason I wrote my work down, just to talk about that, if you remember from the video, if you have a hard time factoring, or if you have something difficult to factor that has fractions in it, remember that number you use to factor will always match up to whatever you had up here, after you divided by 2, but before you squared it. So you can use that sort of as a little shortcut, I suppose. And then let's finish this equation. So equals 30. And again, don't be confused where that 30 came from. I just added 5 and 25 together. Okay? From this point, we can now solve with square roots. So let's go ahead and wrap this problem up. So I'll take the square root of either side of the equation, or each side of the equation. I can drop off my parentheses, so now I have just x plus 5 equals. We've talked about that plus or minus anytime you're solving with square roots. And if I think about breaking down 30, 30 would break down into 6 and 5. And then 6 would break down to 3 and 2. So even though it does break down, there's no pairs. So I guess they'd all end up multiplying back together and staying as square root of 30. And then one more step to finish, because I want to know what x equals, not what x plus 5 equals. So I'll go ahead and subtract that 5 from both sides. It will then become a negative 5 on the other side, plus or minus the square root of 30. There's my two answers using the completing the square method.